Hello friends, let's sum up a bit of knowledge that we gathered in the last few videos. So today I would like to show you how to, understand the connection between the graph and the function itself. So once again we start with this one. We discussed it previously in the last video, but let's just go a bit deeper. So there are so-called 7 steps that we should go through in order to totally understand the behavior of the function or the graph. So number 1 is the domain, and the domain in this case is the question, what can we put for x? And the answer is everything. So the domain is x is just a real number. Number 2, what is the behavior of the function if x is running towards infinity? So with other words, limit x is running towards infinity of f of x. Now you know if x is increasing, then x cubed of course is increasing as well, and x cubed is way bigger than x, or the development of x cubed is way stronger than the development of x. So we only look at x cubed, and if x is big, x cubed is also very big. So plus infinity in this case. What's happening if x is running towards minus infinity, if we have f of x? Well, you see, if we put a huge negative number and we take it to the 3rd power, it still remains huge but also negative. So we call it actually small number, but the absolute value is huge, so it's big. So we have minus infinity. We actually do not care about what's happening with x because it's way too small compared to x cubed. Number 3, do we have any kind of symmetry? The answer is yes. Well, we only have odd exponents here, but I hope that you remember, if f of x equals to f of minus x for every x, then we call it symmetric considering the y-axis. And if we have f of minus x equal to minus f of x, then we call it symmetric considering the origin. And this is exactly the case we have here. Let us see. F of x equals to x cubed minus x. If we just put minus x instead of x here, we're gonna have minus x cubed minus x. Then you have minus x cubed because of 3 times minus, and minus minus becomes plus. So obviously we do not have it to be equal of f of x, but if you look carefully, compare this one with minus f of x, you will see this is exactly where we are. So minus x cubed minus x, this is just minus x cubed plus x, and voila, I'm done. Right? So those two are equal. That means we are symmetric considering the origin. Nice to know. Would it help us? Yes, it would. Or it will. Why? Well, because I just really have to understand what's happening in the half of the graph. The other half must be symmetric. So it really helps. We don't do it at school or at the university in order to kind of bother you or something. We really need it, okay? Let's move on. Number 4. What do we have here? Well, the 4th point is we could try to understand what are the 0 points. So x cubed minus x equals to 0. Take x out, you get x squared minus 1 equal to 0. So x1 already 0. Here we got x squared minus 1 equal to 0. And I just prefer to use the binomial formulas wherever it is applicable or possible. So x2 is equal to 1 and x3 is equal to minus 1. We got those 3 0 points. We had it also from the last time, from the last video. Number 5, what do we have here? Well, let's start working with the derivative. F prime of x is 3x squared minus 1. We put it equal to 0. We bring 1 to the right hand side. We have 3x squared equal to 1. We divide it by 3. We have x squared equals to a third. Now we can take a square root. So x1 is minus. Now you see that it makes perfectly sense with symmetry, because also here, of course, we should have it with min and max. Now what else do we need? Well, of course, the second derivative as well. Let's change the color. F second prime of x would be equal to 6x. So f second prime of, well, let's take square root of a third. It's 6 times a square root of a third. Well, it's positive. I don't care about the real value. I know it's positive, so the second derivative is telling me what's happening afterwards. So we're going up, so we must have been down. That means we are at minimum. So that means that's a min. So that means minimum. This is the x value. And in order to compute the y value, we just should substitute a square root out of a third into our equation. So that means we have a square root out of a third cubed minus square root out of a third. And if you're familiar with algebra a little bit, you see we just have a third times square root of a third minus a third itself, minus a square root of a third. So we have a third of a square root minus 1 whole square root, so that means we got minus 2/3 square root of a third. So this is what we have here. And since I have the information that the function is symmetric considering the origin, I know that max, this is really important here, is at minus square root out of a third and plus 2/3. See, so if we have minimum right there, max is right here. So this is kind of important. I don't have to compute anything, which is really nice. All right, number 6 is the points of inflection. In order to do this, we compute the second derivative, which is just 6x. So 6x equals to 0. We've done it last time. Of course, x is 0. Third derivative is 6. The third derivative at 0 is still 6, so unequal to 0. So we have point of inflection. And with the x value of 0 and the y value is, well, obviously 0 again because of the function. And now we got all the information we needed, right? We knew we had 0 points at -1 at 1 and at 0, of course. Then, well, square root out of a third is approximately 0.33. So square root out of this is approximately 0.58, I would say. So we're somewhere here. And we are at minus 2/3. So we'll make it a little bit closer to 0. So we're somewhere here. Kind of. Okay, so that's the min. Correspondingly, that's the max. That's the point of inflection. Now, let's go back. What about our behavior towards infinity? Well, we are running to minus infinity if x is approaching minus infinity, and we are running to plus infinity if x is running to plus infinity. So what's happening here is, I'll do my best, such a nice curve. All right, thanks for watching. See you in the next video. Bye bye, all the best.